This is the second video recording I will be doing in the series labeled Life and the Physical Environment. So today we're going to talk about hydrogen ions and how they influence ecological systems. This figure is just a pH scale of hydrogen ion concentration, and it extends from 0, which is highly acidic, to 14, which is highly alkaline. And the pH of rainfall can vary a great deal around the world. Among dissolved substances in water, hydrogen ions deserve pretty special mention because they are extremely reactive with other compounds. For example, in pure water, a small fraction of the water molecules, H2O, break apart into their hydrogen and hydroxide ions, and the concentration of hydrogen ions in a solution is referred to as its acidity. So acidity is commonly measured as pH, and that is defined as the negative logarithm of hydrogen ion concentration. So if you go ahead and look down here at this equation, we have pH is equal to the negative log of the hydrogen ion concentration. So essentially, water containing a high concentration of hydrogen ions has a low pH value, whereas water containing a low concentration of hydrogen ions has a high pH value. And so we're going to categorize water with low pH values as acidic, water with a mid-range value of 7 as neutral, and water with a high pH value as basic or alkaline. Natural rain or snow can vary a great deal in pH depending on the presence of different chemical compounds in the atmosphere that affect that pH value. So hydrogen ions, because of their high reactivity, dissolve minerals from rocks and soils, and this enhances the natural solvent properties of water. For example, in the presence of hydrogen ions, the calcium carbonate found in limestone dissolves readily, according to the chemical equation that I listed up in the top left corner of this slide. So essentially what's happening here is that calcium ions are important to life processes, and their presence at high concentrations is vital to organisms like snails because they form shells made of calcium carbonate. Mollusks are less abundant in streams and lakes that are low in calcium, for example. Therefore, hydrogen ions are essential for making certain nutrients available for life processes. At high concentrations, hydrogen ions negatively affect the activities of most enzymes. In addition, high concentrations of hydrogen ions cause many heavy metals to begin dissolving in water. Those heavy metals, including arsenic, cadmium, and mercury, are highly toxic to most aquatic organisms. So the normal range of pH of lakes, streams, and wetlands is between 5 and 9. However, some bodies of water can even have lower pH values. Sometimes lower pH conditions have a natural cause. Bogs, for example, are aquatic habitats with vegetation such as sphagnum mosses that release hydrogen ions into the water and thereby make the water more acidic and unsuitable for many other species of plants. And so other bodies of water have low pH as a result of human influences. For example, the release of sulfur dioxide and nitrogen dioxide from coal-powered industrial plants became a major environmental issue in the 1960s. At that time, ecologists in Russia, China, Northern Europe, and the United States, as well as Canada, began to notice that many bodies of water were becoming more acidic and less hospitable to numerous species of fish and other aquatic organisms. They also noticed that trees were dying, particularly in the spruce fir forests that existed at high elevations in these regions of the world. And it turned out that these areas with more acidic bodies of water and dying trees were all far downwind of industrial areas with coal-powered factories that had very tall smokestacks. Years of data collection revealed that sulfur dioxide and nitrogen dioxide emitted into the atmosphere by these smokestacks were converted to sulfuric acid and nitric acid in the atmosphere. These acids were transported downwind and then came back down to Earth as acid deposition, which some of you may know as as acid rain. The acid deposition occurred in two forms: as gases and particles that stuck to plants and soil. That's called dry acid deposition, and then also as rain and snow, which is called wet acid deposition. So acid deposition lowered the pH of precipitation, and as a result, water of unusually low pH was entering streams, lakes, and forests. So most aquatic species can't tolerate water with a pH lower than 4, and so these bodies of water became toxic to many aquatic organisms, which included insects and fish, of course. So in forests, acid deposition has several effects. First, it leaches the calcium out of the needles of conifer trees like spruce. It also causes increased leaching of soil nutrients that trees require, including calcium, magnesium, and potassium. And acid deposition causes aluminum to dissolve in the water. Although aluminum naturally occurs in the soil, it is typically not in a form that is available to plants. And dissolved aluminum can negatively affect a plant's ability to take up nutrients. Collectively, these effects of acid deposition make trees more susceptible to the harmful effects of natural stressors that include drought, diseases, and extreme temperatures. So, while the trees do not die directly from acid deposition, they become more susceptible to other causes of death. Because acid deposition interacts with so many other natural stressors, scientists recognize that acid deposition has contributed to the death of trees in North America, Europe, as well as Asia. However, the complexity of the interactive effects has made it difficult to accurately estimate how much of the observed tree death is directly attributable to acid deposition. So, once scientists understood the causes and consequences of acid deposition, they began to explore solutions. In the United States, legislation required the installation of smokestack scrubbers that force smokestack gases through a slurry of limestone and water, and that removes the gases. The use of those scrubbers caused a major reduction in the amount of acidic compounds going into the atmosphere. The U.S. Environmental Protection Agency, or the EPA, reports that from 1980 to 2010, emissions of sulfur dioxide declined by 79%. So at the end, that's just something to think about, right? We control our influence on these ecological systems, and this is a great example of how we can act and how we can institute regulations to kind of balance out the influence that hydrogen ions have in our ecological systems. I think that's about all I want to talk about for this section. If you have questions, let me know. Thank you.